Imagine for a moment that everything you know, every memory, every object, every star that has ever lit the sky, was concentrated in a state so extreme that words almost refuse to describe it. It was not a point floating in nothingness, because nothingness itself did not yet exist. There was no space in which that point could be located, nor a clock marking a beginning, because time had not yet learned how to move forward. When we speak of the birth of the universe, we are not talking about an explosion in a specific place, but about the simultaneous emergence of space, time, energy, and matter, as if reality itself had taken its first breath. As you try to understand this beginning, it is natural for your mind to search for familiar references, something like a spark, a blast, or an expansion from a center. But these images are only mental crutches. The origin of the universe did not occur on a pre-existing stage. The stage was born with the event. Space did not expand into something larger. Space itself began to stretch, like an infinite sheet that suddenly discovers it can grow in all directions at once, without edges, without an outside. In those first instants, speaking of seconds or minutes makes no sense. Time as you experience it now, with its orderly flow and clear direction, did not yet exist as a defined physical concept. The equations suggest that, if you go back far enough, time behaves strangely. It loses its linear character and becomes almost indistinguishable from space. In that primitive regime, asking what came before is like asking what lies north of the North Pole, a question that seems valid in everyday language but loses meaning within the correct physical framework. What is fascinating is that these ideas are not born of poetic speculation, but of a careful reading of the present universe. When you look at the sky, you are in fact looking back in time. Light takes time to travel, and every distant galaxy is an ancient photograph. The farther you look, the younger the universe you see. Following this logic to its limit, astronomers discovered a faint, omnipresent signal, a thermal echo that fills all of space, a kind of whisper from the origin. That radiation, cooled to just a few degrees above absolute zero, is the direct imprint of a universe that was once hot, dense, and uniform. That primordial heat speaks to us of a past in which matter was not organized into stars or atoms, but existed as an almost perfect soup of energy. Particles appeared and disappeared, were born and annihilated, in a frenetic balance that is hard to imagine today. There were no structures, no boundaries, no privileged directions. The universe was nearly the same everywhere, an extreme homogeneity in which even the tiniest irregularity, however small, would end up being crucial. Here is where one of the most surprising ideas enters. Everything that exists today, galaxies, clusters, vast voids, arose from minuscule imperfections. Tiny fluctuations, mere differences in energy density, were amplified by expansion. It is as if an apparently calm water surface hid invisible ripples that, over time, turned into giant waves. The universe was not born structured. It learned to organize itself slowly. But before that organization could even begin, time had to acquire a direction. Today, we take it for granted that time flows from past to future, that memories point backward and uncertainty forward. But that arrow of time is not an obvious property of the cosmos. It emerges from very special initial conditions. At the beginning, the universe was in a state of extraordinary order, with surprisingly low entropy. That seemingly technical detail is what allows time to make sense, what allows processes to occur, and causes to precede effects. Think of time as a narrative that needs a coherent starting point. Without that ordered initial state, there would be no story, only noise. The expansion of the universe, by creating new space and allowing energy to disperse, marks the beginning of that narrative. From there, time begins to differentiate, to flow, to become something measurable. Although in those earliest moments, measuring it is more an abstraction than a lived experience. Curiously, although the early universe was simple in its composition, it was extremely complex in its laws. The fundamental forces did not behave as they do today. Gravity, electromagnetism, the strong nuclear force, and the weak force were so intertwined that distinguishing them was impossible. At unimaginably high temperatures, nature operated under unified rules, as if all interactions were different expressions of a single deep principle. Only as the cosmos cooled did these forces begin to separate, specialize, and define the behavior of the world you would eventually come to know. In this context, time is not only born, it also becomes sensitive to matter and energy. It is not a rigid, independent background, but something that curves, stretches, and slows, depending on what happens in the universe. From the beginning, time and space form a joint entity, a kind of dynamic fabric that responds to the presence of energy. This idea, which today seems sophisticated, is essential for understanding why the origin of the universe cannot be described as a classical event. As the universe expands and cools, the first stable particles begin to appear, then protons and neutrons, and later simple nuclei. Each of these steps occurs in a sequence that depends critically on the rate of expansion and the passage of time. If the universe had expanded too quickly, matter would never have had the chance to clump together. If it had expanded too slowly, everything would have collapsed again. Time, in that sense, acts like a cosmic metronome, marking the proper tempo for reality to be built layer by layer. And yet, in this birth, there is no intention or conscious design, only simple laws applying themselves relentlessly. Beauty emerges, not because someone planned it, but because the initial conditions allowed it. Time begins to advance, not in order to reach a destination, but because the universe has no choice but to evolve. That inevitability is, paradoxically, what makes everything so astonishing. Now, as you follow this thread forward, it becomes inevitable to ask how it was possible to reconstruct such an ancient history from a present that seems disconnected. The answer lies in the consistency of physical laws. The universe preserves memory of its origin, not in archives, but in patterns. Every equation describing expansion, every observation of the cosmic background, every distribution of galaxies is a clue pointing backward toward that initial state in which time began to take shape. In the first instance after the universe's birth, the concept of duration was so strange that even physicists must resort to abstract scales. We speak of fractions of a second so small that they defy any human intuition. Yet, within those tiny intervals, the rules of the game were set. The geometry of space, the rate of expansion, the way energy transforms into particles, all of it was defined very early, as if the universe had written its entire prologue before there was even the possibility of a reader. One of the deepest ideas is that time may not always have been as you experience it now. Near the origin, the distinctions between past and future blur. Some formulations suggest that, in that extreme regime, time behaves like an additional spatial dimension without a privileged direction. Only when the universe cools and expands enough does asymmetry emerge. That clear sense that yesterday is fixed and tomorrow is open. This transition is not trivial. It marks the moment when causality begins to make sense. Before that, speaking of cause and effect is problematic because the very notions of before and after are fuzzy. Time, in a way, crystallizes. It becomes operational. From then on, processes can link together, structures can persist, and memory becomes possible, even though billions of years will still pass before there is anyone capable of remembering. As the universe continues to expand, energy dilutes and temperature drops. This cooling allows particles to bind together stably. The first nuclei of hydrogen and helium appear as the primary building blocks of everything that will come later. At this stage, time already plays a more recognizable role. There are clear sequences, temporal windows in which certain processes can occur, and if they are missed, they do not return. The universe begins to show a remarkable sensitivity to its own rhythm. It is here that the first human intuitions about time find a distant echo. Long before science existed, ancient cultures already perceived time as cyclical or linear, eternal or created. These intuitions, though laden with mythology, reflect a genuine question the universe poses from its very birth. Is time infinite, or did it have a real beginning? Modern physics responds with a surprising affirmation. Time, as we understand it, appears to have begun with the universe itself. This does not mean that the origin is fully understood. On the contrary, the closer we try to look, the blurrier the image becomes. Current theories work admirably well from a fraction of a second after the birth. But as we approach the initial limit, the mathematics becomes unstable. Quantities grow without bound. Curvatures become infinite, and the usual language of physics ceases to be reliable. This point, known as a singularity, is less a physical description than a sign that our conceptual tools break down. Far from being a failure, this limitation is an invitation. It indicates that time and space, in their most extreme form, require a deeper description, a synthesis of relativity and quantum mechanics that we do not yet fully possess. Meanwhile, what we can say is that the early universe was not lawless chaos, but a system governed by precise principles, even if they are difficult to extrapolate to our everyday intuitions. The birth of time also implies the birth of irreversibility. From that moment on, certain processes can occur only in one direction. The universe expands, structures form, usable energy slowly degrades. This tendency, known as the increase of entropy, is the physical basis of the arrow of time. It is not an external imposition, but a direct consequence of extraordinarily ordered initial conditions. Understanding this, the origin of the universe ceases to be merely a cosmological question and becomes an existential one. Everything you experience, every passing moment, is connected to that remote beginning. The flow of time in your daily life is a direct continuation of the expansion that began billions of years ago. You are not separate from the birth of the cosmos. You are part of its ongoing development. Time does not advance for no reason. It advances because the universe continues to change. Every passing second is proof that the cosmos has not yet reached final equilibrium. As long as there are differences, gradients, possibilities for transformation, time will continue to have meaning. And that meaning inevitably traces back to the first instant when the universe ceased to be an abstract concept and began to exist as a dynamic reality. Thus, when we speak of the birth of the universe and the first intuitions about time, we are not talking about a distant, alien event. We are talking about the origin of experience itself. Time began when the universe started telling itself a story, and you, now, are one of the most recent chapters in that immense narrative that is still unfolding. Before we go on, I want us to do something very simple. Stop for a second and think about how you imagine space. You probably picture it as a vast empty stage, a kind of immense box in which galaxies, stars, and planets float. Now think of time as something else entirely, like an invisible clock that advances without asking permission, marking seconds while everything happens within that stage. That image is intuitive, almost inevitable. And for centuries, it was exactly how humanity understood reality. Space on one side, time on the other. Independent, calm, immutable. But here comes the first surprise, one of those that permanently change how you look at the world. The universe does not work that way. Space and time are not two separate things. They never were. They are two faces of the same entity, so deeply intertwined that trying to separate them is like trying to talk about the front of a sheet of paper without mentioning the back. When something happens in the universe, it does not happen only in a place or only at a moment. It happens in an inseparable combination of both. Every event has a direction in space and a position in time, and together they form what we call space-time. This may sound abstract, so let's move a little closer. Imagine you are watching a movie. On the screen there are images, colors, movement. But that movie does not exist only as a sequence of frames or only as a duration. It exists as a story that needs both the order of images and the passage of time to make sense. The universe works in a similar way. It is not just a collection of places, nor just a timeline. It is a four-dimensional story that writes itself as it goes along. Now, let me ask you a direct question. Have you ever felt that time passes more slowly or more quickly? Perhaps during an endless wait, or in a conversation so pleasant that the hours disappear without you noticing. That subjective experience already gives us a hint that time is not as rigid as it seems. Physics takes that intuition much further and tells us something even more unsettling. Time is not only perceived differently, it actually flows differently depending on how you move and where you are. Here is where space enters the scene as something alive, not as a passive backdrop, but as a structure that responds, deforms, and interacts with matter and energy. The presence of a star, a planet, or even your own body modifies the space-time around it. This is not a poetic metaphor. It is a literal description. Gravity is not a force pulling things from a distance. It is the result of that curvature. Objects move by following the natural paths of a space-time that is no longer flat. Think of a stretched elastic sheet. If you place a heavy ball in the center, the sheet sinks. Now, if you roll a marble nearby, it does not fall because someone pushes it, but because it follows the curvature of the sheet. That image, though imperfect, is powerful. Stars and planets do not attract each other for no reason. They move because space-time tells them how to move, and that space-time is not rigid. It is dynamic. It responds. It evolves. Most fascinating of all, this relationship works both ways. Matter tells space-time how to curve, and space-time tells matter how to move. It is a constant dialogue, a silent conversation that has been taking place since the birth of the universe. Nothing is truly at rest. Not even the vacuum is passive. The vacuum has structure, energy, properties that influence how the universe expands and transforms. Now let us return for a moment to the origin. When the universe was born, space and time emerged together. There was no space waiting for time to start running, nor time waiting for a stage to be created. They arose as a single entity, extremely compact, intensely curved, where distances and durations were almost indistinguishable. In that primitive state, Talking about a second or a meter makes little sense. Everything was compressed into an extreme geometry. As the universe began to expand, that fabric stretched. Not only did galaxies move away from one another, the very space separating them expanded as well. And here, I want you to imagine something concrete. Do not think of an explosion. Think of fermentation, like a lump of dough rising uniformly. There is no privileged center. Every point sees the others recede. From any location, the universe appears to expand in the same way. That is space-time in action, growing, evolving, changing its scale. And time, meanwhile, also changes its pace. In regions where gravity is intense, time slows down. Near a massive star, or worse, near a black hole, clocks tick more slowly compared to those far away. This is not science fiction. It is a direct consequence of space-time geometry. Time does not flow the same everywhere. It stretches and compresses, just as space does. Let me involve you a bit more. If you could travel near an extremely massive object and then return, you would discover that less time had passed for you than for those who stayed far away. Not because your clocks malfunctioned, but because time itself followed a different path for you. Every trajectory in the universe is a trajectory in space-time, and not all of them traverse time at the same rate. This forces us to rethink a deeply rooted idea, that of a universal present. There is no absolute now that everyone shares. What is present for you may be past or future for another observer in motion. The universe has no master clock. It has millions of local clocks, all keeping time according to their own paths through space-time. Here, space-time begins to seem almost organic. It adapts, responds, stores memory. Gravitational waves, for example, are literally vibrations of space-time, ripples that propagate when violent events occur, such as the merger of black holes. It is not that something moves through space. It is space itself that ripples. Imagine a calm lake disturbed by a stone thrown from far away, a perturbation that travels while carrying information. And if space-time can vibrate, curve, and expand, then it is not far-fetched to think of it as a living entity in a physical sense, not biological, but dynamic, active, in constant transformation. It is not an object. It is a process. It is not a container. It is part of the content. Let's go a little deeper, because this is where the story becomes even more intimate. Everything you do, every step you take, every thought you have, happens within that flexible fabric of space-time. You are not simply in the universe. You are moving through it in a very specific way. Even when you believe you are standing still, you are in fact racing forward through time at great speed, carried along by expansion and by your own cosmic trajectory. I want you to imagine space-time now as a river, not a river of water, but a river of possibilities. You do not choose whether you flow or not. You are always flowing. What you can choose is how you move within the current. The speed at which you move through space affects the speed at which you move through time. It is a constant trade-off. The faster you move through space, the more slowly you advance through time. Not because time is angry with you, but because that is how the geometry of the universe is built. This exchange between space and time reveals something profound. They are not separate entities cooperating with one another. They are aspects of a single structure. When one changes, the other responds. The universe does not distinguish between moving and aging. Both are forms of motion through space-time. You are traveling through that structure right now, following a unique and unrepeatable line that will never exist again. And here, another powerful idea emerges. The past does not disappear. The future does not yet exist in the classical sense, but all events are part of space-time as a whole. Some interpretations suggest that the entire universe, from its birth to its final fate, could exist as a kind of block. Not because everything is predetermined in a fatalistic sense, but because space-time contains all possible trajectories. The flow of time would then be a local experience, not a global property. This can feel unsettling, so let's go slowly. It does not mean your life is written like a rigid script. It means the universe can be described as a structure in which all events are geometrically connected. The fact that you feel time passing, remember the past, and anticipate the future is related to how your consciousness navigates space-time, not to a universal tape unspooling everywhere at once. Let's return to the movie analogy. The entire reel exists, but you experience only one frame at a time. Space-time would be the whole reel. Your experience of time is the projector advancing. You do not see the future because you have not yet reached that frame, not because it is absent from the global structure. Now think again about the early universe. In that initial state, space-time was so curved, so compressed, that the usual notions of distance and duration collapsed. There, space-time was not only alive, it was in its most intense form, almost unrecognizable. As time passed, that intensity softened. The universe became more spacious, colder, slower. Space-time stretched like a deep breath that has not yet ended. This stretching has profound consequences. As space grows, galaxies separate, energy disperses, and the universe changes its character. But space-time does not lose its dynamism. Even in regions that appear empty, there is still activity. Expansion continues. Quantum fluctuations persist. The fabric never becomes completely still. And here I want to involve you again. When you look at the night sky, you are not seeing objects suspended in a dead void. You are seeing nodes of a cosmic network embedded in an expanding space-time. The light reaching your eyes has traveled along curved paths, has been stretched by expansion, has lost energy along the way. Each photon is a messenger that has been in dialogue with space-time for billions of years before meeting you. Even your own body is part of this conversation. Your atoms follow the rules of space-time. Your heart beats according to processes that depend on temporal order. Your aging is a local manifestation of the arrow of time. You are not outside the phenomenon you observe. You are immersed in it. Thinking of space and time as a single living entity changes how you understand the universe. But it also changes how you understand yourself. You are no longer a spectator watching from the outside. You are a trajectory, a line drawn in the fabric of the cosmos. Your existence is a small stroke in an immense structure that began unfolding with the birth of the universe. And the most astonishing thing is that this fabric, though it may seem stable, continues to evolve. The future of space-time will depend on expansion, on the energy it contains, on the interaction between gravity and entropy. Nothing guarantees it will always be as it is now. Just as it was born, it can transform in ways we are only beginning to imagine. For now, hold on to this idea as we continue together. The universe is not a static stage on which history happens. The universe is the history. Space and time are not the background. They are the silent protagonists that sustain every event. And you, listening to this, are not outside the story. You are happening within it, here and now, traveling without pause through a living entity we call space-time. Imagine that we are together, observing the universe from very far away. not from a specific point, but from an impossible perspective, as if we could see everything at once. The first thing we would notice would not be an explosion or chaotic motion, but something much quieter and more persistent. The universe is expanding, not dramatically, not with a roar, but with the constancy of something that has never stopped doing so since its birth. And here I want to pause with you for a moment, because cosmic expansion is often misunderstood, and understanding it properly completely changes how you perceive the cosmos. When we say the universe is expanding, we do not mean that galaxies are shooting outward from a center. There is no privileged point from which everything recedes. Expansion happens everywhere at once. The space between things increases. It is the very fabric of the universe that stretches. If this sounds strange, it is because it is, but also because we are used to thinking of space as rigid, when in fact it is dynamic, flexible, active. Let me offer you a simple image. Imagine drawing dots on the surface of a deflated balloon. Each dot represents a galaxy. Now you begin to inflate the balloon. No dot moves on the surface by itself, yet all of them move away from one another. From any dot, the others appear to recede, and the farther away they are, the faster they seem to do so. There is no center on the surface of the balloon, and yet the expansion is real. That is how the universe works, only in more dimensions and without an outside into which it inflates. This expansion is not an isolated theoretical idea. It was discovered by observing the light from galaxies. When we analyze that light, we see it shifted toward redder colors, not because galaxies are red, but because space itself has stretched while the light was traveling. Light waves lengthen along with the universe. It is as if space itself stretches the light in mid-journey, leaving us a clear trace of its continuous growth. Now I want you to think about something important. If the universe is expanding today, and has been doing so for billions of years, then in the past, it must have been smaller. And not just a little smaller, but vastly smaller, denser, hotter. Cosmic expansion is inseparable from the cooling of the universe. They are two sides of the same process. As space stretches, energy is spread over an ever larger volume, and as energy disperses, temperature drops. This is where the story becomes almost intimate. In its earliest moments, the universe was intensely hot. Not hot like a star, but hot in a way that defies any everyday comparison. Energy was so concentrated that matter as we know it could not exist. There were no atoms, no nuclei, no stable particles. Everything was motion, interaction, constant transformation. And yet, as the universe expanded, it began to cool, slowly, relentlessly. It was not an abrupt cooling, it was a gradual descent, like a campfire dying out through the night. At first the change is rapid, then increasingly slow, but it never fully stops. This cooling allowed complexity to emerge, step by step. Imagine a cosmic kitchen. At the beginning, the heat is so intense that no ingredient can stay together. Everything falls apart. But as you lower the heat, structures begin to form. First simple combinations, then more stable ones. The universe worked the same way. When the temperature dropped enough, particles could bind without being immediately destroyed by the surrounding energy. Cooling opened windows of opportunity. These windows are crucial. Each stage of cooling allowed something new, and if the expansion rate had been different, those opportunities would have been lost. A universe that expands too quickly cools too quickly, preventing matter from organizing. One that expands too slowly collapses under its own gravity. Ours seems to walk an extraordinarily precise tightrope. And here I want to involve you directly. Everything that exists today, from galaxies to the atoms in your body, depends on that balance having been maintained for billions of years. Cooling is not just an abstract physical process. It is the reason there is something structured rather than nothing. As the universe cooled, the dominant radiation began to lose its grip. For a long time, cosmic energy was governed by light, by particles traveling at extreme speeds, colliding endlessly. But with expansion, that radiation diluted. Heavier matter began to take center stage. It was a quiet but decisive shift. The universe moved from being a luminous ocean to a setting where matter could settle. And that ancient glow did not disappear completely. It is still here, surrounding you right now. It is an extremely cold, almost imperceptible radiation that fills all of space uniformly. It is the thermal echo of a young universe, a kind of luminous fossil that tells us, without words, that the cosmos was once a blazing, compact place. This ongoing cooling also speaks to the passage of time on a cosmic scale. The universe does not only expand in space, it also ages thermally. Each era has its characteristic temperature. Each stage leaves behind conditions that will never return. Primordial heat cannot be recovered. Expansion causes usable energy to disperse, marking a clear direction in cosmic history. Here, a powerful idea emerges. The universe does not repeat itself. It does not retrace its steps. Its expansion and cooling are irreversible processes. This gives the cosmos a narrative, an evolution. The universe has thermal memory. It remembers its hot past through signals we can still measure, but it cannot return to it. And notice this: while the universe cools on large scales, locally hot regions can arise. Stars, for example, are islands of heat in an ever cooler ocean, but even they depend on global cooling. Without an expanding, cooling universe, there would be insufficient thermal contrast for energy to flow, for stars to shine, for complex processes to occur. Put another way, the cold of the universe is just as important as its initial heat. It is the gradient between the two that makes structure possible. Expansion creates space. Cooling creates opportunity. Together, they build the stage for everything that comes after. Now imagine the future for a moment, without going too far ahead. If expansion continues, the universe will keep cooling, more and more, slowly. There is no hurry. The cosmos has all the time in the world, but that cold future is directly connected to the hot past. They are part of the same process, the same cosmic breath that began with the birth of space and time. As we move forward in this story, hold on to this feeling. The universe did not explode and then calm down. The universe stretches and cools continuously, like a story telling itself without stopping. And you, right now, exist in a very special phase of that process, an intermediate point where there is still enough heat for stars to exist, but enough cold for complexity to arise. Let's keep walking together, because now that we understand that the universe expands and cools, we must face a less obvious but much deeper consequence. Expansion does not only separate galaxies or cool radiation, it also transforms what the universe is able to do. It changes its possibilities. It is as if, with every stretch, the cosmos loses certain options and gains new ones. This happens so slowly, it is almost invisible, yet so constantly that it defines the entire future. Think of cooling not as a loss, but as a transition. At the beginning, the universe was so hot that everything was possible and nothing was stable. As time passed and temperature dropped, some possibilities closed forever, while others became viable. It is a silent exchange. The cosmos sacrifices extreme freedom in exchange for structure. And that decision, if we can call it that, is what allows a recognizable world to exist. As the universe expanded, particles began to move with less violence. Collisions became less destructive. Interactions grew more selective. Imagine a crowded room where everyone is pushing chaotically. No stable group can form. Now imagine the room growing larger. Movement softens. Spaces appear where it becomes possible to stay for a while. In this way, little by little, the universe allowed matter to stop being fleeting chaos and begin to have memory. This cooling also affected light in a profound way. At first, radiation dominated everything. Light constantly collided with matter, like a dense fog where nothing can be seen at a distance. But a moment came when the universe became cold and spacious enough for light to travel freely. It was as if a veil were lifted. For the first time, the cosmos became transparent. That instant marked a definitive boundary in the universe's history. From then on, light could travel vast distances uninterrupted, carrying information from one place to another. And that same light, stretched and cooled by expansion, is what we detect today as a faint background filling space. It is not just thermal residue. It is a photograph of the moment when the universe ceased to be opaque and began to reveal its interior. But here is something even more interesting. That background is not perfectly uniform. It has tiny variations, minute differences in temperature, and those irregularities are not errors or noise. They are seeds. They are the imprints of a universe that was no longer perfectly homogeneous, that was beginning to break its symmetry. In those minimal differences, the future structure of the cosmos is written. Let me bring you a little closer to this idea. In a cooling universe, regions that are just slightly denser cool differently and expand at slightly different rates. And gravity, patient and persistent, begins to amplify those differences. Not suddenly, not violently, but slowly, like a whisper that insists for billions of years. Here, expansion and cooling play a delicate game. Expansion tries to separate everything, to dilute matter, to isolate each region. Gravity, by contrast, tries to gather, to bring together, to create structures. The universe is the result of that unstable balance. If expansion completely won, there would be no structures. If gravity dominated, everything would collapse. Cooling modulates this tension, allowing both processes to coexist. And I want you to notice something important. None of this happens in a hurry. The universe has a patience that defies the human scale. Processes that would be unbearably slow for us are, for the cosmos, natural steps. Cooling does not aim for an end. It simply happens, setting the pace at which new forms of organization can arise. As the global temperature decreases, the energy available to do work also changes. Energy does not disappear, but it becomes less useful. It spreads more uniformly. This tendency is crucial because it establishes a clear direction for cosmic history. The young universe was full of extreme thermal contrasts. The older universe is more uniform, colder, quieter. And here I want to involve you again, because this process is not foreign to your existence. Everything you do depends on energy differences. Your body works because there are gradients, because not everything is at the same temperature, because energy flows. That flow is possible thanks to a universe that has not yet reached thermal equilibrium. Expansion and cooling create the stage on which complexity can exist for a limited time. Notice this paradox. The universe cools, and yet for a long era that cooling allows local sources of heat to arise. Stars are born because matter can collapse and heat up in specific regions. But even that stellar heat is temporary. Stars shine because the universe as a whole is cold. Without a cold environment, there would be no contrast, no energy flow, no sustained light. Expansion also affects the duration of these stages. A universe that expands more rapidly reduces opportunities for interaction. One that expands more slowly prolongs processes. Our universe seems to have found a rhythm that allows a long era of structures, a kind of cosmic plateau where complexity has time to develop. But this rhythm is not constant. Expansion itself can accelerate or decelerate depending on the universe's energy content. This adds another layer of depth. Cooling does not follow a simple line. There are eras when change is faster, others when it seems almost frozen. The universe does not age uniformly. It ages in stages. Imagine the cosmos as a being that breathes very slowly. Each expansion is a gentle inhalation. Each cooling, a prolonged exhalation. There is no rush, no immediate destination, just a continuous process that transforms the conditions of possibility. In this slow, almost meditative rhythm, the universe leaves certain forms behind and opens space for others. And while all this happens, expansion also stretches the very concept of distance. Regions that were once causally connected cease to be so. Light emitted today from certain places will never reach others. Cooling is accompanied by progressive isolation. The universe becomes larger, but in some senses also lonelier. This is not a tragedy. It is a natural consequence. The cosmos does not seek communication. It simply evolves. And in that evolution, it creates unique moments. The era in which you exist is one of them. An interval where the universe is neither too hot nor too cold, neither too dense nor too empty. A point of transient balance. When you understand cosmic expansion and the cooling of the universe this way, you no longer see them as abstract processes. You see them as the pulse of cosmic history itself. Every second that passes, the universe is slightly larger and slightly colder than before. You do not notice it, but it is real. It is happening right now as you read these words. And here, without yet moving on to what comes next, we can hold on to one clear and powerful idea. The universe does not merely exist. It is in process. Expansion and cooling are not past episodes. They are the continuous present of the cosmos. Everything to come, every future structure, every transformation will depend on how this silent stretching continues to shape what is possible. If we keep moving together through this story, we reach a key moment, one of those quiet turning points that change everything without making a sound. The universe, which for a long time was dominated by energy and radiation, slowly begins to tilt toward another protagonist. Matter starts to gain ground. It does not happen all at once. There is no precise instant when one could say, here everything changed. But the balance shifts. And that shift marks the beginning of something entirely new, the possibility of structure. I want you to imagine the universe as a vast field after a storm. For a long time, the wind was so strong that nothing could stay in place. Everything was motion, agitation, constant exchange. But now, very slowly, the wind begins to calm. There is still energy, there is still movement, but it is no longer enough to prevent some things from staying where they are. Matter begins to settle. This change has a deep cause. As the universe expands and cools, radiation loses its influence. The energy of light is diluted by the expansion of space. It stretches, it weakens. Matter, by contrast, even as it disperses, retains its mass. Little by little, without drama, matter becomes the dominant component. And with that silent victory, gravity begins to truly make itself felt. Until now, gravity had been present, but its effect was limited. In a universe that is too hot and dominated by radiation, gravity cannot organize much. It is like trying to build sandcastles in the middle of a restless tide. But when matter takes center stage, gravity finds its opportunity. And gravity does not need haste. It only needs time. Here, I want you to pause with me for a moment. Gravity does not create structures immediately. It is not an explosive force. It is persistent, patient, almost stubborn. It works best when nothing interrupts it. In a universe that cools and expands calmly, gravity can begin to amplify small differences. Regions with slightly more matter attract even more matter, not because they are special, but because physics is relentless. Remember those small irregularities we talked about before, those tiny differences in density. This is when they begin to make sense. In a perfectly uniform universe, nothing would happen. Everything would remain the same forever. But the real universe was not perfect. It had minute imperfections. And those imperfections are the origin of everything that comes next. Imagine an almost flat surface, barely rippled. At first glance, it seems smooth, but if you look closely, there are small depressions. Over time, anything that falls will tend to accumulate there, not because those places demand it, but because the geometry allows it. This is how gravity works in the young universe. Slightly denser regions begin to grow, very slowly, feeding on their surroundings. And here, something beautiful happens. The expansion of the universe tries to pull everything apart, but gravity, locally, begins to win small battles. Not on the scale of the entire universe, but in specific regions. It is a constant tug of war. The cosmos stretches, but in some places matter resists. It gathers, it concentrates. It begins to form the first skeletons of structure. I want you to picture it as a network beginning to take shape. Not an orderly network, but an irregular web with nodes and filaments. Matter flows slowly toward denser zones, leaving emptiness in other regions. The universe begins to lose its initial uniformity. Contrasts appear, places with a lot of matter and places with very little. And those contrasts are fundamental, because where there is contrast, there is history. Where there is difference, there is evolution. The universe begins to organize itself not by design, but by consequence. Gravity does not plan, it simply acts. And in doing so, it turns small variations into gigantic structures. But there are still no stars. There are still no galaxies as we know them. What appears first are diffuse concentrations, enormous clouds of matter moving slowly, obeying the geometry of space-time. They are the seeds of everything else, embryonic structures that will take millions and then billions of years to mature. And here I want to speak to you directly. All of this happens on a timescale so vast that it defies any human intuition. For the universe, millions of years are barely a slow blink. Matter is in no hurry. It moves according to simple laws, but the results, seen from afar, appear almost intentional. They are not. They are inevitable. As these concentrations grow, gravity begins to heat matter locally. As matter falls into denser regions, gravitational energy is converted into heat. This heating is crucial. It marks the beginning of a new stage, where the universe is no longer just a place that cools uniformly, but a setting with active, dynamic, energetic regions. But before stellar fire ignites, there is a long preparation. Matter must organize itself, lose energy, collapse in a controlled way. Too fast, and everything disperses. Too slow, and expansion wins. Once again, the balance is delicate. Meanwhile, radiation, now relegated to a secondary role, remains present as a silent background. It no longer dominates, but it does not disappear. It is the constant memory of an earlier era, a witness to the hot past of the cosmos. Matter advances, but it does not forget where it came from. I want you to notice something important. The appearance of the first structures is not just a physical event. It is a qualitative change in the history of the universe. Before, everything was statistics and averages. Afterward, specific places appear, each with its own story. The universe ceases to be a single homogeneous whole and becomes a mosaic of distinct regions. Here, cosmic diversity is born, not yet in complex forms, but in potential. Some regions will become galaxies, others will remain empty. Some will host intense processes, others will stay almost unchanged for eons. Destiny ceases to be singular and fragments into multiple trajectories. And this fragmentation is essential. Without it, there would be no local stages where complexity could arise. There would be no places where energy concentrates enough to ignite stars. No stable regions where long-term processes could persist. The victory of matter is, in reality, the victory of possibility. As we continue forward, I want you to hold on to this image. The young universe, already cold compared to its origin, begins to show scars, reliefs, depths. Matter, guided by gravity, begins to write its own geography into space-time. Nothing is finished yet, but the map is starting to take shape. Let us keep going, because now the universe begins to show something that did not exist before: identity. Up to this point, matter had begun to cluster, yes, but we still could not speak of defined objects. These were diffuse regions, broad concentrations, like rough drafts of something that did not yet know what it wanted to be. But gravity, patient as always, is not satisfied with sketches. Over time, it begins to refine its work. I want you to imagine those vast clouds of matter as fog spread across an immense valley. At first, everything is soft, without clear edges. But in certain places, the fog is slightly thicker. Not much, just enough. And that small difference changes everything. Gravity begins to pull more matter toward those points, and the more it pulls, the stronger its influence becomes. It is a silent feedback process. Nothing explodes. Nothing accelerates abruptly. It simply happens. Here, time plays a fundamental role. Without enough time, gravity could not build anything. The first structures are not born from violent events, but from extremely slow accumulations. Millions of years pass without, from a human perspective, anything significant seeming to happen. But the universe does not measure progress as we do. For it, consistency is more powerful than speed. As these regions grow, they begin to decouple from the general expansion. And this is a key idea. Until now, everything expanded along with the universe. But there comes a moment when, locally, gravity is strong enough to resist that stretching. In those zones, expansion stops dominating. Matter begins to fall in on itself. For the first time, the universe allows something to remain still in a profound sense. And here, I want to speak to you directly. This is one of the most important moments in all of cosmic history. Even though there are no witnesses, no light, no sound, It is the moment when the first gravitationally bound systems appear, places where matter no longer simply follows expansion, but begins to write its own local history. These first structures do not resemble today's galaxies. They are enormous, crude, irregular. They have no defined shape. They are more like halos, extended regions where matter, both visible and invisible, accumulates, creating deep gravitational wells. At the bottom of those wells, ordinary matter begins to behave differently. It can lose energy. It can cool locally. It can collapse further. Here, a subtle but crucial distinction appears. Not all matter behaves the same way. One part of it interacts with radiation, can cool by emitting energy, can clump into more compact forms. Another part, by contrast, only feels gravity. It does not cool easily. It does not form small structures. But its presence is decisive. It is the invisible scaffolding upon which everything else organizes. Without getting technical, think of this as the skeleton of the universe, a structure that cannot be seen, but that defines where visible forms can appear. The matter that can cool falls into those gravitational wells and begins to concentrate into ever denser regions. It is as if the universe were building invisible molds before pouring in the final contents. And now something extraordinary happens. As matter falls, it compresses. And as it compresses, it heats up. This heating does not contradict the global cooling of the universe. They are different processes occurring on different scales. The universe as a whole continues to cool, but locally, in these knots of matter, energy concentrates. The first truly dynamic regions appear. I want you to imagine this contrast, an increasingly cold and dark cosmos, crossed by points where energy begins to accumulate. Like embers igniting in an endless night, they do not yet shine like stars, but they are already charged with potential. History begins to accelerate in these places. As matter continues to collapse, hierarchical structures form. Small concentrations merge to form larger ones. The universe builds from the bottom up. It does not create large structures all at once. It assembles them patiently, piece by piece. Each merger releases energy. Each reorganization leaves a mark on the local geometry of space-time. And here, something fundamental for the future occurs. These regions begin to thermally isolate themselves from their surroundings. Global cooling no longer completely dominates them. Within them, matter can continue to collapse, losing energy through internal processes. This opens the door to a qualitative change. Matter ceases to be merely a distributed substance and becomes something capable of sustaining complex internal processes. But not everything progresses uniformly. Some regions win the race, others fall behind. Some become increasingly dense, others are stripped of matter and remain almost empty. The universe fragments into different destinies. Cosmic inequality appears. And that inequality is not a flaw. It is the engine of complexity. I want you to pause with me on this idea. If the universe had remained perfectly uniform, there would be no history. Everything would be the same everywhere. There would be no special places. The emergence of structure is, at its core, the emergence of differences that can persist over time. It is the birth of cosmic geography. On large scales, these structures begin to organize into striking patterns. Long filaments of matter connect dense regions. Between them, vast voids open up, nearly devoid of content. It is not random chaos. It is a network, a cosmic web arising from simple laws applied over immense times. The universe begins to resemble less a uniform fog and more a complex fabric. And within the nodes of that network, conditions grow ever more extreme. Matter falls, spins, flattens. Organized motions appear. Gravitational energy transforms into heat, into radiation, into internal dynamics. The stage is set for the next great leap, though we are not going to take it yet. I want you to notice something important before closing this section. None of this happens because the universe wants to create structures. It happens because the conditions allow it. Expansion has slowed enough. Cooling has opened new possibilities. Matter has won the battle against radiation. And gravity, with its relentless consistency, has done the rest. This is the moment when the universe ceases to be only a story of expansion and cooling and becomes a story of places. Places with their own trajectories. Places where time begins to be felt differently. Places that, later on, will host even more complex processes. Here, without stars yet, without visible light dominating the sky, the universe has already changed forever. The victory of matter is not loud, but it is decisive. The first structures already exist, not as finished objects, but as physical promises inscribed in space-time. Let us move on, because now the universe is about to do something that will change its appearance forever. Up to this moment, everything has taken place in darkness, not metaphorical darkness, but literal darkness. Although matter is already organizing, although structures are beginning to take shape, the cosmos remains a place without its own sources of light. There are no stars. There is no glow. Only vast regions of gas slowly cooling inside enormous gravitational wells. But this apparent calm is deceptive. Something is taking shape. I want you to imagine an endless night, a cosmic night lasting hundreds of millions of years. During that time, matter falls, accumulates, spins, compresses itself. Every particle obeys gravity without knowing it is part of a larger process. There is no intention, but there is consequence. And the consequence is inevitable. Density increases. As gas concentrates in the central regions of the first structures, something crucial happens. Gravitational collapse cannot continue indefinitely without resistance. When matter compresses, it heats up. And that heating begins to change the rules of the game. For the first time since the universe's global cooling, places appear where temperature rises again in a sustained way. Let me involve you here. This heating is not violent or instantaneous. It is slow, progressive, like rubbing your hands together for a long time until you begin to feel warmth. Gravity works tirelessly, converting motion into thermal energy. The gas, ever denser, ever hotter, begins to behave differently. There comes a point when the internal pressure of the gas begins to oppose collapse. It is a fragile balance. Gravity pushes inward, thermal pressure pushes outward. For a while, neither fully wins, but gravity has an advantage. It keeps accumulating mass, and with more mass, its influence grows. And here, the decisive moment arrives. At the centers of these concentrations, the temperature reaches values so high that atomic nuclei can no longer ignore one another. They come close enough to interact in an entirely new way. We are not talking about ordinary collisions. We are talking about nuclear fusion. This is the ignition of stars, not as a sudden spark, but as a profound transition in the behavior of matter. The simplest nuclei begin to merge, releasing energy in the process, and that energy changes everything. For the first time, the universe has internal sources of light and heat. I want you to pause with me at this instant. The universe, which for so long was a place that only cooled, now has points where energy flows outward continuously. These are not fleeting explosions. They are stable processes, capable of lasting millions or even billions of years. Darkness begins to retreat. But these first stars do not resemble the ones you know today. They are gigantic, massive, intense. They are born in a universe very different from the present one. The material they are made of is almost pure, lacking heavy elements. This makes them hotter, more luminous, and paradoxically more short-lived. They shine with brutal intensity, but live briefly in cosmic terms. And here something fascinating appears. These stars do not just illuminate the universe, they transform it. Their radiation is so intense that it begins to affect the surrounding environment. The gas around them becomes ionized, heated, reorganized. Light is not just illumination, it is an active force. The luminous era is not merely a visual change, it is a profound physical change. I want you to imagine the universe as a landscape covered in thick fog. For a long time, that fog covers everything. Now, little by little, lighthouses appear. Not many at first. Isolated points of intense light. Around each one, the fog dissipates. Not uniformly, but in bubbles that grow over time. These bubbles of light expand, meet, overlap. The universe ceases to be opaque. Stellar radiation opens paths. For the first time since the birth of the cosmos, light can travel great distances without being immediately trapped. The universe enters a new stage of active transparency. But this light comes at a price. The first stars consume their fuel quickly. Their great mass makes them unstable. They live fast, they shine fiercely, and they die young. Some collapse violently, others disappear, leaving behind dense remnants. But even in death, they leave a lasting mark, because these stars accomplish something that had been impossible until now. In their cores, nuclear fusion creates new elements, not just energy, but different matter. The universe, which until then was composed almost exclusively of the simplest ingredients, begins to enrich itself. New chemical possibilities appear. I want you to notice the depth of this change. The ignition of stars is not just the beginning of light, it is the beginning of material diversity. The cosmos begins to manufacture the building blocks that will allow more complex structures in the future. All of this happens as a direct consequence of the victory of matter and the prior cooling. Nothing is disconnected. The luminous era, then, is not uniform or tranquil. It is dynamic, uneven, full of contrasts. Regions where stars are born in large numbers coexist with vast spaces that remain dark. The universe does not light up all at once. It does so in fragments, in waves, in generations. And here I want to speak to you directly once more. When you look at the night sky today and see stars, you are seeing the result of this process that began billions of years ago. Every point of light is an heir to those first stars that broke the primordial darkness. Without that first ignition, the universe would still be a cold and silent place. But we have not yet reached the end of this story. Light not only reveals, it also transforms. Stellar radiation alters the pace of new structure formation. It accelerates some processes, slows others. It introduces complexity. The universe is no longer just gravity and expansion. Now there is feedback, interaction, cycles. This is the true entry of the universe into an active, creative phase. The luminous era marks the moment when the cosmos begins to illuminate its own structure, not because it has consciousness, but because physical laws inevitably lead it there. Let us continue, because once the first stars ignite, the universe can never be the same again. Light does not only reveal what exists, it also alters the course of events. Wherever a star begins to shine, the environment changes in character. Nearby gas is no longer simply matter falling obediently under gravity. It becomes an active medium, heated, stirred, pushed by intense radiation. I want you to imagine this process as a new conversation within the universe. Until now, gravity spoke almost alone, attracting, gathering, slowly shaping. With stars ignited, a second voice appears. Radiation begins to respond. It heats the gas, ionizes it, expands it. In some places, it halts collapse. In others, it reorganizes it. The universe enters a stage of constant physical dialogue. Young stars emit enormous amounts of energy. That energy does not remain still. It propagates, interacts, pushes. Gas that once fell freely toward the centers of structures now encounters resistance. Shock waves are created. Entire regions change their fate. The formation of new stars no longer depends solely on gravity, but on the balance between attraction and energetic feedback. Here, something fundamental appears. Starlight introduces rhythm. Some regions become highly active for a short time and then fade out. Others remain quiet for long periods before igniting. The luminous era is not uniform. It is episodic. The universe learns to beat. And as this process continues, stars do something even deeper than illuminate and warm. Inside them, they transform matter irreversibly. Nuclear fusion not only releases energy, it also changes the identity of atomic nuclei. Heavier elements begin to exist, first in small quantities, then in increasing amounts. The universe begins to become chemically complex. I want you to pause for a moment on this idea because it is easy to overlook. Before stars, the universe had very few material options. After stars, the range widens. Each stellar generation slightly modifies the composition of the cosmos. Matter is no longer almost pure hydrogen and helium. It begins to be enriched, and that enrichment changes what can happen next. The most massive stars live fast and die spectacularly. In doing so, they return to their surroundings not only energy, but also the products of their interiors. The surrounding space fills with new ingredients. Gas that was once simple now carries a history, and that history will influence the next generation of stars. Here, the universe begins to show memory. Not conscious memory, of course, but physical memory. Present conditions depend on past processes. Each stellar cycle leaves a mark that is not erased. The cosmos is no longer just a system that evolves. It is a system that accumulates experience. As millions of years pass, illuminated regions multiply. Bubbles of ionized gas grow, connect, and eventually dominate enormous volumes. Primordial darkness retreats definitively. The universe becomes, on average, a place filled with freely traveling light. The luminous era reaches its maturity. But this light does not travel intact. Space continues to expand. Distances increase. Radiation stretches. The stars born today illuminate a larger and colder universe than that of their predecessors. Each stellar generation lives under slightly different conditions. Time continues to leave its mark. And here I want to involve you again. When we observe distant galaxies, we are seeing different stages of this luminous era superimposed. Some show regions of intense star formation. Others appear calm, aged. The sky is a temporal archive. Each point of light is a story frozen at a different moment. Light also becomes a fundamental tool for structure, not only because it allows observation, but because it carries energy and momentum. Radiation can expel gas from certain regions, empty them, prevent new stars from forming there. Elsewhere, the compression induced by that same radiation can trigger local collapses. The effect is neither simple nor uniform. It is a game of balances. The universe, then, enters a phase of self-regulation. Stars are born, modify their environment, and in doing so influence the possibility that more stars will be born. There is neither uncontrolled growth nor total shutdown. There are cycles, waves, pulses. Over time, structures that were once diffuse begin to acquire clear identity. Stable systems of gravitationally bound stars appear. Light ceases to be an isolated phenomenon and becomes a characteristic property of entire regions. The universe begins, for the first time, to resemble something recognizable from our current perspective. But this familiarity is deceptive. The early luminous era is more intense, more violent, more extreme than the one we know today. Stars are born with enormous masses. Radiation is harsher. The environment is less forgiving. It is a young universe, still rough, still learning how to organize its energy. And yet, it is precisely this intensity that accelerates transformation. Light not only illuminates, it also erodes. It wears down initial conditions and opens space for new configurations. The cosmos refines itself through excess. As chemical enrichment advances, matter becomes more efficient at losing energy. Gas can cool better. It can fragment. It can form smaller and longer-lasting structures. The luminous era prepares the ground for even greater diversity, not only of stars, but of entire systems. I want you to notice something essential here. None of this occurs in contradiction with global expansion and cooling. Everything happens within that framework. The universe as a whole continues to grow and cool, but locally it creates islands of activity, regions where energy concentrates for long periods. It is in those islands that complexity finds temporary refuge. Light, then, is not an end. It is a means. It is not the destiny of the universe. It is a necessary stage. A phase in which the cosmos learns to transform its energy in increasingly sophisticated ways. The luminous era is the moment when the universe becomes visible, but also the moment when it becomes historically rich. And here, without getting ahead of ourselves, we can say something clearly. The ignition of stars was not just a physical event. It was a change in the narrative of the cosmos. From that moment on, the universe can no longer be described solely in terms of expansion and gravity. There are cycles, there is inheritance, there is feedback. When you look at a star today, you are seeing a distant descendant of that first ignition. You are seeing a continuation of a story that began when the universe decided, without any intention, to allow itself to shine. Now the universe enters a particularly delicate stage, a phase where nothing is guaranteed and everything depends on an almost impossible balance. Up to this point, gravity has been the great architect, gathering matter, building structures, igniting stars. But from this point onward, that same gravity encounters a silent adversary it cannot ignore: energy. Not as something abstract, but as a real presence that pushes, heats, expands, and resists. I want you to think of it this way. Gravity always wants to unite, to close, to collapse. Energy, by contrast, tends to disperse, to expand, to separate. The universe lives in the permanent tension between these two opposing tendencies. Neither can win completely without destroying the stage on which both act. And it is precisely this tension that allows something to exist beyond chaos or total collapse. Look at it on a nearby scale. A star exists because gravity tries to crush it inward, while the energy released in its core pushes outward. If either of these forces fully prevailed, the star would disappear, either collapsing violently or dispersing into space. Its existence is a constant negotiation, a pulse maintained over millions or billions of years. Now let's widen the view. The same balance occurs at all scales, in gas clouds, in star clusters, in entire galaxies. Gravity gathers, energy responds. Nothing is static. Everything is sustained because two opposing processes contain each other. This balance is not comfortable. It is fragile. A small change is enough to break it. A gain of mass here, a loss of energy there, and the system enters another phase. The universe does not seek eternal stability. It only finds temporary states where it can remain for a time before transforming again. Think about regions where stars are born. Gravity concentrates gas, but as the star ignites, the energy it releases begins to affect its surroundings. It heats the surrounding gas, expels it, disperses it. The very star that was born thanks to gravity can prevent others from being born nearby. It is a fascinating paradox. Creation contains within itself the limit of its own continuity. Here, the universe begins to behave like a regulated system. There is no unlimited growth of structures. Energy acts as a natural brake. Where gravity becomes too efficient, energy responds forcefully. Where energy dominates too much, gravity waits its moment. And I want you to pause with me on this idea, because it is easy to miss. The universe is not a machine moving in a single direction. It is a system of dynamic balances. Each stage arises from the previous one, but also corrects it. Nothing runs away without consequences. On large scales, this balance defines the shape of galaxies. Gravity tries to make them collapse into compact structures. Energy, through motion, radiation, and internal processes, introduces rotational order, pressure, stability. Galaxies are neither closed spheres nor chaotic clouds. They are geometric compromises between opposing forces. And this compromise is not perfect. There are losses. There are always losses. Energy radiates into space. The universe does not recycle everything. Over time, that energy becomes less useful. It disperses. It dilutes. But while that process is not complete, while gradients still exist, the balance can be maintained. Here, something deeply tied to the passage of time appears. The balance between gravity and energy is not eternal because the energy available to oppose gravity changes. As the universe ages, useful energy decreases. Systems that once could sustain themselves for long periods begin to become unstable. But we are still in a privileged stage, a stage where the energy released by stars is sufficient to maintain complex structures, where gravity has not fully won, where the universe has not fallen into thermal silence. I want you to think of this like a taut rope. Too much tension, and it snaps. Too much slack, and it holds nothing. The universe walks that rope. Each structure is a controlled oscillation. Each star, each galaxy is a temporary equilibrium. And this equilibrium does not occur only in individual objects. On a cosmic scale, the expansion of the universe also participates in this negotiation. Expansion acts as a form of distributed energy, separating regions, diluting densities. Gravity tries to counteract it locally. The result is a universe fragmented into islands of stability within an expanding ocean. These islands are not completely isolated. They interact, they merge, they collide. And each interaction tests the balance again. When two large structures meet, gravity intensifies. Energy is released in enormous quantities, and the system must find a new way to sustain itself or transform. Here, the universe shows its most dramatic character, even though, from within, we perceive it as a slowness. Processes that last billions of years are, in reality, sequences of continuous adjustments. Nothing happens just once. Everything is constantly recalibrated. And I want you to notice something important. This fragile balance is not an anomaly. It is a direct consequence of the laws governing the cosmos. If gravity were a little stronger, the universe would have collapsed too early. If the energy released in internal processes were different, structures could not be maintained. The universe we observe is the result of an extremely precise balance, not designed, simply allowed. As we continue forward, this balance will become increasingly difficult to sustain. Not because something fails, but because the universe changes. Energy disperses, expansion continues, gravity waits. The future will depend on how these forces continue to negotiate their dominance. There is something here that deserves calm attention, almost as if we lowered our voice. That balance between gravity and energy is not only a condition for things to exist, it is also a promise with an open but not infinite date. Every structure you see in the universe, from a solitary star to an entire galaxy, is sustained by a temporary agreement, a silent pact renewed moment by moment, as long as there is enough energy to keep gravity at bay. At the heart of a star, this pact is felt with particular clarity. Gravity pushes everything toward the center with relentless consistency, while the energy released in the core responds by pushing outward. It is not a violent struggle. It is more like a steady pulse, like two hands pressing with just enough force not to let go or crush each other. But that pulse depends on a finite resource. Energy does not arise from nothing. It is obtained by transforming matter, and that matter inevitably runs out. When fuel begins to run low, the balance becomes more fragile. It does not break immediately. First, it adjusts. The star slowly changes its internal structure, searching for new ways to sustain itself. It is a gradual, almost elegant process that can last millions of years. From the outside, everything seems stable. From the inside, the balance becomes increasingly demanding. This same principle extends far beyond individual stars. Galaxies also live by delicate balances. Gravity tries to compact them, while the ordered motion of their components, rotation, and the energy accumulated in their internal systems prevents total collapse. Galaxies are not immobile masses. They are dynamic systems, constantly readjusting. But here, an important difference appears. On galactic scales, the balance does not depend on a single energetic process, but on many overlapping ones. Stars being born and dying, gas heating and cooling, collective motions redistributing energy. It is a more complex, more resilient balance, but not an eternal one. As time passes, the universe changes the context in which these balances exist. Expansion continues. Distances increase. Interactions between structures become less frequent. Galaxies begin to live more isolated histories. And that isolation has profound consequences. In a young universe, collisions and encounters were common. These interactions released enormous amounts of energy, reactivated internal processes, renewed the balance. In an expanding and cooling universe, such encounters become rare. Existing structures must increasingly make do with the energy they already have. Here, the balance begins to tilt slowly, not toward immediate collapse, but toward a quieter future. Gravity never disappears. It is always there, waiting. Useful energy, by contrast, disperses. It radiates. It dilutes into ever larger space. The universe does not lose energy in absolute terms, but it loses the ability to use it in a concentrated way. I want you to think of this like a campfire on a cold night. At first, the fire is intense. Heat is concentrated. You can warm yourself, cook, see around you. Over time, the embers are still there. The energy has not vanished completely, but you can no longer do the same things with it. The balance changes in nature. Something similar happens in the universe. As long as energy gradients exist, clear differences between hot and cold regions, the balance between gravity and energy can sustain complex structures. When those gradients diminish, gravity begins to gain the upper hand, not because it has become stronger, but because its opponent has weakened. This does not mean the universe is about to collapse. It means that the era of comfortable balances is limited. Each structure has its window of stability. Some are short, others long, but all are embedded in an evolving context. And here a deep idea appears, one that runs through the books on which this account is based. The universe is not designed to sustain structures forever. It is designed, if we may use that word, to allow them for a time. That time is sufficient for complex processes to occur, for local histories to arise, for diversity to exist. But it is not infinite. The fragile balance between gravity and energy is, in fact, the condition that makes history possible. Without it, everything would have collapsed too early or dispersed without forming anything. Thanks to it, the universe was able to explore an enormous variety of configurations before moving towards simpler states. When you look at a stable star, a well-defined galaxy, you are seeing a temporary solution to a cosmic equation. It is not a final state. It is a valid answer for a specific interval. And that transitory nature does not diminish its beauty. It adds to it. Because knowing that something is finite changes how you see it. Balance is not valuable because it is eternal, but because it allows something to exist instead of nothing organized. It allows the universe to be interesting for a fraction of its history. The cosmos has learned to sustain itself through delicate balances, but those balances already contain the seed of its future transformation. Nothing breaks suddenly. Everything shifts slowly. There is something deeply reassuring in realizing that the universe was not born perfectly ordered. In fact, if it had been, we probably would not be here talking about it. What allowed everything to happen was not perfection, but a slight imperfection, almost imperceptible at first, like a whisper in the middle of silence. Imagine for a moment the newborn universe as an immense, almost smooth surface, not completely uniform, but extraordinarily close to it. If you could run your hand across it, you would feel only small ripples, tiny variations in density and energy. Nothing dramatic, nothing that seemed important. And yet, in those irregularities, the entire future history was written. These small differences did not arise because the universe wanted variety. They arose because, at very deep scales, nature cannot avoid chance. In the earliest moments, when everything was compressed and energies were extreme, fluctuations were inevitable. Not large differences, but minimal variations, like the almost invisible trembling of a calm water surface. I want you to think about this carefully. We are not talking about uncontrolled chaos. We are talking about surprising precision. The irregularities were small, but not non-existent. And that is the key. If they had been too large, the universe would have collapsed into isolated regions without global structure. If they had been too small, nothing would have stood out enough to grow. The universe found, without seeking it, a middle point. These initial fluctuations were imprinted into the very structure of space and time. As the universe expanded and cooled, those differences did not disappear. On the contrary, they became seeds. Slightly denser regions began to attract a bit more matter. Nothing spectacular at first, just a tiny advantage. But gravity is patient. It does not need large differences to act. It only needs time. And the universe had plenty of time. Thus, regions that were slightly denser slowly accumulated more matter than their surroundings. Not because they were special, but because chance had placed them just one step ahead. Each additional particle reinforced the difference. Each small gain made the next one more likely. The process fed back on itself without hurry, almost elegantly. Here, a beautiful idea appears. The universe does not build its large structures from great events, but from small advantages accumulated over immense periods. Nothing imposes itself all at once. Everything consolidates step by step. These initial irregularities had no defined shape. They were not places destined to become galaxies. They were simply regions where density was slightly higher. But over time, those differences began to organize space, as if the universe were drawing an invisible map where some routes became increasingly traveled. Imagine a crowd walking aimlessly across a huge plaza. At first, everyone moves randomly. But if for any reason, some people concentrate a bit more in one area, that concentration attracts others. Not because there is a clear reason, but because it is easier to join where people already are. Little by little, paths, currents, patterns appear. They were not planned, but they become real. The universe works in a surprisingly similar way. Small irregularities create preferential routes for matter. Gravity reinforces those routes. And over time, what began as a tiny fluctuation becomes a recognizable structure. What is fascinating is that this process preserves the memory of the initial chance. The way galaxies are distributed, the voids between them, the great cosmic webs, all of this reflects, amplified, those tiny primordial irregularities. The present universe is an expanded version of an ancient tremor. And here I want to invite you to look at this idea from another angle. Chance, in this context, is not absolute disorder. It is a source of diversity. It is what prevents everything from being the same everywhere. Thanks to these variations, the universe can explore different possibilities at the same time. Some regions evolve faster, others lag behind. Some form dense structures, others remain almost empty. This inequality is not a flaw of the system. It is its essential feature. As structures grew, the role of irregularities did not disappear. It only changed scale. New variations emerged within already formed systems. In a gas cloud, small density differences could determine where a star formed and where it did not. In a galaxy, local fluctuations could influence the distribution of its components. Nothing happens in a perfectly uniform way. There is always room for the unexpected. And that margin is enough for history to take different paths in different places. I want you to hold on to this feeling. The universe does not follow a rigid script. It follows rules, yes, but within them there is space for variation. The laws determine what is possible. Chance decides which possibility is realized in each place. This balance between law and chance is deeply creative. Physical laws establish the framework. Chance fills in the details. Without laws, there would be no coherence. Without chance, there would be no history. Over millions and billions of years, these small irregularities are amplified, combined, transformed. Some disappear. Others leave lasting marks. The universe selects, not consciously, but through stability. Configurations that can sustain themselves persist, those that cannot dissolve. And here, something almost poetic appears. The universe does not eliminate chance. It integrates it. It turns it into structure. It transforms it into large-scale order without erasing its unpredictable origin. When we observe the distribution of galaxies, we see filaments, clusters, vast voids. It looks like deliberate architecture, but in reality, it is the result of countless small decisions, made without intention, amplified by gravity and time. None of this happens in a hurry. The universe has no urgency. It can afford to explore possibilities slowly. Each irregularity has time to show how far it can go. And you are part of this process, because the place from which you observe the universe is also determined by a chain of small, accumulated differences. Nothing was written in detail from the beginning. There were only the conditions that allowed something to happen. There is a moment in the history of the universe when everything begins to look stable, as if the major decisions had already been made. Galaxies exist. Stars repeat themselves by the millions. Patterns can be recognized. And yet, beneath that appearance of order, chance continues to whisper. It does not shout. It does not interrupt. It simply slips into the small spaces where no one is looking. Think of the universe as a vast, silent landscape. From afar, it seems motionless, almost eternal. But if you move closer, you discover that in every corner, tiny, almost imperceptible things are happening that change the course of what will come next. A cloud that cools a little faster, a movement that slightly deflects the gas, an interaction that happens a little earlier or a little later. Minute details, enormous consequences. In these scenarios, chance no longer creates the rules, but it does decide how they are played. Physical laws set the limits, but within those limits there is room for infinite variation. The universe does not need to be unpredictable in everything to be creative. It is enough to leave a few doors open. And here, something beautiful appears. Two regions of the cosmos, born under almost identical conditions, can end up telling very different stories. Not because one is special and the other is not, but because chance tipped the balance almost imperceptibly at some early moment. A small difference is enough to open divergent paths. This happens again and again. Inside a galaxy, some regions fill with stars, while others remain quiet and dark. There is no single reason. There is no hidden design. There is a delicate combination of conditions and coincidences. The universe does not optimize, it explores. And that exploration is slow, patient. There is no urgency. Time is broad, generous. Small irregularities have space to develop, to try, to disappear, if they do not work. Nothing is forced. Everything is allowed to evolve. What is interesting is that, over time, chance does not destroy order, it enriches it. Structures do not become chaotic, they become diverse. Each region acquires its own character. Each local story differs from the next. The universe fills with nuances. Even when we look at processes that seem to repeat themselves, like the birth and death of stars, they are never exactly the same. There is always a variation, a subtle difference in duration, in intensity, in environment. Chance introduces personality into processes that, on paper, appear identical. And here I want you to connect this with yourself, without forcing it. The fact that such different places exist in the universe is not an isolated accident. It is a direct consequence of this microscopic freedom. History was not written in detail from the beginning. There were only the conditions that made many stories possible. The universe does not need to decide everything in advance. It allows itself to discover itself as it moves forward. Every small irregularity is an open question. Some lead nowhere. Others, over time, become lasting structures. But none are discarded immediately. There is something deeply calming in this idea. The cosmos is not rushing toward a rigid destiny. It moves forward, leaving space for the unexpected. And that space is precisely what keeps complexity alive for so long. As the universe ages, the great differences soften. Expansion separates regions. Energy disperses. Opportunities for drastic changes diminish. But even then, chance does not disappear. It takes refuge in the final details, in the last adjustments, in the small deviations that can still make a difference. The universe becomes quieter, yes, but never completely uniform. There is always some variation left, some echo of the initial tremor, reminding us that everything began with a slight imperfection. And perhaps that is one of the most comforting ideas of all. The cosmos did not need to be perfect to create beauty. It simply needed not to be identical everywhere. A bit of difference, a bit of freedom, a margin for things to happen in different ways. When you look at a star for a few seconds, everything about it seems stable. It does not change shape. It does not move. It does not flicker beyond the effects of the atmosphere. It gives the impression that time does not affect it. But if we widen our gaze, if we let the scale stretch, something different happens. The star begins to reveal itself as a process, not as an object. Each star is a story unfolding at its own pace, a story written with matter, pressure, and energy. From the instant it ignites to the moment it transforms into something else, its existence follows a precise sequence, not rigid, but recognizable. And that sequence allows something extraordinary, using stars as clocks of the universe, not clocks that mark hours or days, but clocks that indicate eras, the presence of certain types of stars, their brightness, their color, their mass. Speak of the cosmic time in which they exist. It is enough to observe them carefully to know whether the universe is young, mature, or entering a calmer phase. I want you to imagine the universe as a nocturnal landscape where some lights last only a short time and shine with overflowing intensity, while others remain lit for immense spans, almost without visible change. That difference is not accidental. It is a direct consequence of how each star manages its energy. The most massive stars live fast. Their gravity is so intense that it accelerates internal processes. They consume their fuel voraciously. They shine with a force that seems disproportionate, as if trying to compensate for their short existence with intensity. Their lives may last only a few million years, a sigh in cosmic terms. Their presence indicates an active universe, still rich in dense matter. Smaller stars, by contrast, proceed patiently. Their internal balance is more moderate. Energy is released slowly. They can remain stable for billions of years. Some of them will continue shining long after many others have disappeared. Their light is a sign of continuity, of longevity, of a universe that has learned how to endure. Here, something fascinating happens. By observing a population of stars, we do not just see points of light. We see a distribution of ages. We see overlapping generations. We see traces of the past and signals of the future coexisting in the same instant. The sky becomes a temporal record, and we do not need to look far to understand it. Within a single galaxy coexist young and old stars, bright and dim, ephemeral and persistent. Each occupies a different position on the great cosmic calendar. Their current state tells us how much time has passed since certain conditions were common. Stars also mark time not only by how long they last, but by how they change. Throughout their lives, their brightness and color slowly shift. These changes follow clear patterns, not rushed, not abrupt. They are gentle, predictable transformations, like the aging of a landscape through the seasons. The universe uses these changes as indicators. Where young, bright stars dominate, cosmic time is different from regions dominated by dimmer, more stable stars. It is not a question of value, but of context. Each stage has its own quiet beauty. And here I want you to connect with the central idea of this section. Stars do not measure time because someone designed them to do so. They do so because their existence is governed by energetic processes with very precise durations. Gravity and energy, once again, establish a rhythm, and that rhythm becomes a reference. When a star exhausts its main fuel, it does not disappear immediately. It changes. It reorganizes itself. It seeks new equilibria. Each transition marks the passage to a new phase of the clock. There is no hurry. The universe does not speed these processes up. It allows them to unfold fully. In this sense, stars are patient witnesses. Their light carries information not only about the space it crosses, but about the time that has passed since their story began. To look at them is to look back, but also to place oneself within a much larger sequence. As the universe ages, the stellar population changes. The most massive stars become rare. The longest-lived ones dominate the landscape. The cosmic clock does not stop, but its ticking becomes slower, more uniform, more silent. This change is not dramatic. It is gradual. The universe does not announce its transitions with noise. It lets them happen, and the stars, with their lives and their wear, mark that advance without the need for words. Let us think about this together, without haste. Imagine that you are walking through an unfamiliar city at dusk. You do not look at a watch, but you know the day is ending. You know it from the light, from the long shadows, from the tone of the sky. No one tells you. You simply feel it. Something very similar happens when astronomers look at the stars. They do not mark hours, but states of cosmic time. Each star is living its own moment of the day. Some are in a kind of dawn, others at full midday, others slowly approaching their twilight. And when you observe many together, when you look at an entire region of the sky, what you see is a temporal landscape. Not a frozen instant, but a superposition of different moments coexisting. Here is where the universe becomes especially eloquent. It does not need words to tell us how much it has lived. Its stars speak for it. The type of stars that dominate a region, the way they shine, the energy they still release, all of that functions as a clue. It is like entering a room and noticing whether it has just been inhabited or has been silent for a long time. Now I want you to imagine a campfire. At first, the flames are high, clear, intense. Then, over time, they become lower, steadier. Finally, embers remain, still hot, but without the initial spectacle. Stars do something similar, not because they suddenly go out, but because their energy changes form, becoming less visible, less exuberant. When the universe was younger, it was full of stars that burned fast and strong. They were signals of a dynamic, active time, full of available matter. As that material is used up, the landscape changes. The stars that remain are calmer, more persistent. The clock does not stop. It simply changes pace. And here I want to involve you directly. When you look at a stable star, one that seems never to change, you are looking at a kind of inverted hourglass. You do not see the grains falling, but you know they are falling. Every second, imperceptibly, the star is moving toward another stage of its story. The universe trusts in that slowness. It does not need fast processes to mark time. It uses long, almost meditative transformations. A star may take millions of years to show an appreciable change, but that change is so reliable that it becomes a reference. This is one of the most beautiful aspects of the cosmos. Its way of measuring time is not abrupt or mechanical. It is organic. It is integrated into the very life of its components. Stars do not carry clocks. They are the clock. And not all of them mark the same thing. Some stars indicate that the universe can still sustain intense processes. Others indicate that certain phases are already behind it. By observing them, one can reconstruct a sequence without having been present. The sky preserves its memory in the form of light. As the universe continues to expand and cool, these signals become even more important. Stars act as milestones. They tell us how far the cosmos has gone on its energetic journey, how much concentrated energy it can still sustain, how much margin remains for new transformations. Think of this as a long nighttime journey. At the beginning, the car has a full tank and the engine responds with force. Later on, the rhythm becomes steadier, more efficient. It is not worse. It is different. Stars reflect exactly that. Not an abrupt decline, but a transition toward calmer states. And what is most interesting is that this cosmic clock is not made for an external observer. It is not designed to be read. It works even if no one looks at it. Its precision does not depend on our attention. The universe measures itself simply by existing. When a star changes phase, when it reorganizes its energy, it is signaling that a certain type of equilibrium is no longer possible for it. And that information, multiplied by millions of stars, reveals the general state of the cosmos, not as an exact date, but as a recognizable stage. Thus, time ceases to be just an abstraction. It becomes visible. It becomes luminous. It turns into something that can cross space and reach us. Starlight does not only travel bringing images, it brings context, age, history. Looking at the sky, then, is like looking at a clock without numbers. You do not know the exact hour, but you know what part of the day you are in. And that, in the end, is enough. At this point, it is worth making a mental pause and looking at the stars from another angle, not from what they illuminate, but from what they leave behind. Because, although they seem eternal, when we observe them, all stars, without exception, move toward a moment when the balance that sustained them ceases to work. And no, that end is not necessarily violent or silent. It depends on the star. It depends on its history. It depends on how much mass it managed to gather when it was born. Each star dies in its own way, and in that difference lies some of the deepest transformations of the universe. Let us think about this together. Throughout its life, a star has been a delicate agreement between opposing force. Gravity pushing inward, energy pushing outward. But that agreement holds only as long as there is fuel to transform. When that fuel begins to run out, the conversation changes tone. At first, it is barely noticeable. The star tries to adapt. It adjusts its internal structure. searches for new forms of balance. It is like someone who, feeling tired, changes pace before stopping. For a while, it seems that nothing serious happens. But the process is irreversible. When energy is no longer sufficient to sustain internal pressure, gravity regains ground. And it does so without haste, but without compassion. The star responds by shrinking, heating up inside, reorganizing what remains of its matter. It is not an immediate collapse, it is a transformation. Here I want you to imagine a house that has lost its main source of energy. The lights go out little by little. Some rooms become unusable. Others overheat. The structure remains standing, but it no longer works as before. Something similar happens inside a star. In less massive stars, this process is relatively calm. They expand, change their appearance, lose outer layers that drift slowly into space. There is no uncontrolled explosion. There is a gradual farewell. The star sheds part of itself and leaves exposed a dense, hot, compact core. That core is one of the first stellar remnants to appear in the universe. It does not shine like a living star, but it is not dead in the common sense of the word. It is more like a cosmic ember, an object that preserves the thermal memory of a long and stable life. And here an important idea appears. The death of a star is not an isolated end. It is a transfer. The matter that was part of its structure returns to space. It disperses. It mixes with the environment. The universe recycles without ceremony. In more massive stars, the story is different. The balance breaks more abruptly. Gravity advances with a force that energy can no longer contain. The core collapses in a brief instant, and that fall releases an enormous amount of accumulated energy. The result is an extreme, luminous event, capable of outshining entire galaxies for a short time. But beyond the spectacle, what truly matters happens afterward. The material that made up the star is violently expelled into space, not as inert dust, but as an enriched mixture, loaded with nuclear history. The environment is transformed. I want you to pause here for a moment. Stellar death is not a loss for the universe. It is a redistribution. What a star produced in its interior over millions of years now becomes available for new stories. Space becomes more complex thanks to these farewells. At the center of these more intense deaths remain even more extreme remnants, objects so dense that they defy intuition. They do not shine like normal stars. They do not behave like planets. They are limit states of matter, sustained by new balances, unknown in everyday experience. These remnants do not exist to be easily seen. They exist because gravity went as far as it could and encountered a final resistance. They are the result of having pushed physical laws to their frontier. And here the universe shows another of its calm but relentless facets. It does not dramatize its endings. It simply continues. One star dies. Another can be born from the material it left behind. Time does not stop. The clock moves on. Stellar death, then, is not a clean cut between before and after. It is a transition, a change of state, a necessary step for the cosmos to continue exploring possibilities. Without these endings, the universe would have remained chemically simple, energetically repetitive. Each stellar remnant is a footprint, a sign that something happened for a long time and then changed. They are like silent ruins in an immense landscape. They do not tell their story out loud, but they are there, holding the past within their density. And what is most interesting is that these remnants influence the future. Their gravity affects the environment. Their presence alters trajectories. They are not passive memories, they are silent actors that continue to participate in cosmic history. When a star stops shining as it once did, the universe is not left empty. On the contrary, it is marked. Stellar remnants are not absolute silences. They are different presences, more discreet but profoundly influential. It is like when someone leaves a room, and even so, their absence reorganizes everything that remains inside. Space feels that departure and adapts. Some of these remnants continue to interact in ways we do not always perceive directly. They do not illuminate their surroundings like a living star, but they curve space around them with surprising intensity. Their gravity is concentrated, precise, almost surgical. Everything that passes nearby notices their presence, even if it cannot see them. Let us think about this together. During a star's life, energy flows outward, marking clear boundaries, pushing matter, generating balance. When that stage ends, what remains is an extreme concentration. A small object compared to the original star, but incredibly heavy, as if an entire story had been compressed into a tiny point. These remnants function as cosmic anchors. They do not need to make noise to influence. Their gravity is enough. They attract gas, deflect trajectories, shape the environment over long timescales. The universe learns to coexist with them, to integrate them into its overall dynamics. And here, a fascinating idea emerges. Stellar remnants are clocks of another kind. They do not measure time through visible change, but through persistence. They remain. They last. They survive entire generations of active stars. They are immobile witnesses to the passage of complete eras. Imagine a landscape where buildings change, lights turn on and off, streets transform, but certain deep structures remain intact for centuries. Stellar remnants play a similar role in the cosmos. They do not dominate the scene, but they uphold the memory of the place. Some of these extreme objects become especially important when they interact with their surroundings. If they have matter nearby, they can reactivate in unexpected ways. They do not become stars again, but they do not remain completely inert either. Matter falling toward them releases energy, not because of fusion, but because gravity does its final work. This process is not violent in the traditional sense. There is no uncontrolled explosion. There is a precise, focused release. Nearby space heats up, emits radiation, becomes visible again. The stellar remnant turns into a kind of intermittent beacon, reminding us that even after death, some objects continue to participate actively. Here, the universe shows us something important. The end of a star is not the end of its influence. The form changes, the language changes, but the presence continues. Gravity does not forget, and this has profound long-term consequences. As the universe ages, the proportion between active stars and stellar remnants changes. Each generation leaves behind more residues than new lights. The cosmic landscape slowly fills with dense, silent, persistent objects. It is not a dramatic process. It is gradual. The universe does not turn off the lights all at once. It simply begins to accumulate more memories than novelties, more remnants than births, more stability than change. I want you to imagine a very large hourglass. At the beginning, the grains fall quickly. There is constant motion. Over time, most of them have already passed into the lower chamber. The flow continues, but it becomes slower and slower. Stellar remnants are that lower chamber of the cosmic clock. It is not empty. It is full of accumulated history. These objects also play a key role in the future distribution of matter. Their gravity can gather dispersed gas, trigger encounters, reorganize entire regions. They do not create light by themselves, but they influence where it can appear again. However, as expansion continues and the available energy spreads out, these opportunities become rarer. Stellar remnants begin to live in a larger, colder, more separated universe. Their interactions become spaced out. Their influence becomes local, almost intimate. And here, the tone of the cosmos changes. Intense activity gives way to a deep calm. Not an empty calm, but a calm filled with objects that have already lived their moment of prominence. The universe enters a stage where memory weighs more than novelty. Stellar remnants also speak to us about the limits of matter. They are states where everyday physics is no longer sufficient to describe what is happening. They represent boundaries, points where the normal behavior of matter turns into something extreme. Not because the universe wants to surprise us, but because the conditions push it there. These boundaries are not crossed without consequences. They mark regions where time, space, and energy behave in different ways. They are silent reminders that the universe has layers, depths, levels that we cannot always experience directly. And yet, these objects do not break the overall harmony. They integrate. They find their place in the global balance. The cosmos does not accumulate useless residues. Everything that remains fulfills a function, even if that function is simply to persist. As billions of years pass, stellar remnants become the silent protagonists of a universe that is slowly dimming. They do not shine. They do not heat large regions, but they uphold the gravitational structure. They are the bones of the aging cosmos. Think of this as a night advancing. At first, there are lights on, activity, movement. Later, many lights go out, but the city is still there. Buildings remain. Streets continue. Space does not disappear just because the light fades. Stellar death, then, does not mark a void. It marks a transition toward a different form of cosmic existence, one where concentrated energy is rare, but structure persists, where the past weighs more than the present, yet continues to influence it. These remnants also set the stage for the universe's final phases, not as triggers of new beginnings, but as reference points, as what remains when the active story has been told. And here I want to leave you with a calm image, a vast, silent universe, populated by dense remnants that hold within them the memory of stars that shone for eons. There is no urgency, there is no drama, only continuity. At this point in the journey, the universe is no longer a young place, nor is it old in the human sense of the word, but it has changed its rhythm. The most intense stages are behind it, and now what dominates is a deep calm, a calm slowly built from innumerable silent endings. The brightest stars are no longer the majority. In their place appear objects that are more discreet, denser, more patient. I want us to approach them without haste, like someone entering a dimly lit room after having spent a long time under intense light. At first, it is hard to make out the shapes, but little by little the outlines are revealed. The universe is still there. It simply speaks more softly. Let us begin with white dwarfs, not as concepts, but as presences. A white dwarf is what remains when a star similar to the Sun has finished its active life. It no longer produces new energy. It no longer pushes outward with force. What remains is a compact, hot, incredibly dense core, sustained not by the energy it generates, but by a deep, almost final internal resistance. Imagine an ember buried under ash. There are no flames, no sparks, but the heat persists for a very long time. That is what white dwarfs are like. They do not shine by creation, but by memory. They glow because they still retain the heat of their past, not because they are living something new. And here a key idea appears. White dwarfs do not change quickly. They change slowly, so slowly that the universe can afford to observe them for eons without noticing major differences. They cool gradually, like hot stones left out in the night. Every passing second makes them a little colder, a little quieter. This cooling is not a dramatic process. There is no exact moment when they switch off. They simply continue losing energy until they blend into the cold background of space. They are extremely slow clocks, marking eras so long that our minds can barely hold them. And while this happens, the universe fills with them. Every star that ends a quiet life leaves behind a white dwarf. They do not draw attention. They do not dominate the landscape, but they accumulate. They become a growing, discreet, almost invisible population. Now let us change emotional scale, not towards something more violent, but towards something even more extreme. Neutron stars. If white dwarfs are embers, neutron stars are remnants compressed to the limit of what can be imagined. They do not shine by abundance, but by concentrated intensity. When a very massive star ends its life, what remains is an object so dense that a spoonful of its matter would weigh as much as a mountain. But we do not need numbers to understand this. It is enough to imagine the entire history of a star collapsed into a tiny sphere, spinning, resisting, holding itself together in a radical balance. Neutron stars are silent in a different way, not because they are extinguished, but because their language is strange. They emit precise, regular signals, almost hypnotic, as if the universe had created tiny beacons that mark the passage of time with near obsessive constancy. I want you to pause here with me. These objects do not exist to be beautiful or violent. They exist because gravity went as far as it could without breaking the fundamental rules. They are final states, not provisional ones. They do not evolve into something more complex. They persist. And that persistence changes the tone of the cosmos. The universe begins to fill with objects that no longer actively transform their surroundings, but that also do not disappear. They are stable presences on a stage that becomes increasingly vast and cold. Here, silence begins to take shape, not as total absence, but as a reduction in energetic exchange. Fewer births, fewer explosions, fewer luminous events. The universe does not become empty, it becomes still. White dwarfs continue to cool. Neutron stars continue to spin, ever more slowly. Energy disperses, stretching with the expansion. Everything continues to happen, but at a lower volume. Think of a concert hall after the audience has left. The stage is still there. The instruments too. The air still vibrates faintly with echoes. But the music is no longer being played. The universe gradually enters that state. And here there is something deeply relaxing. There is no final collapse. There is no abrupt destruction. Only a gentle transition toward a stage where almost everything important has already happened. The cosmos does not switch off suddenly. It quiets down. White dwarfs and neutron stars become the silent protagonists of this phase, not because they do much, but because they are there, marking that time has passed. They are the monuments of an active era that is already behind us. As billions of years pass, these populations increasingly dominate. Young stars become rare. The great fires go out. Matter continues to exist, but the available energy to create novelty becomes scarce. And here I want you to connect with the overall feeling. The universe does not become sad, it becomes calm. Like a lake after a long storm, the waves no longer break with force. The surface settles. The water remains deep. This progressive silence is not a failure of the cosmos. It is its natural consequence. Everything that could shine has shone. Everything that could transform has done so. What remains is stability, persistence, memory. Imagine the universe as an enormous house after a celebration that lasted billions of years. It is not empty, nor is it in ruins. It has simply fallen silent. The objects remain in place. The air still holds some of the old warmth, but there is no music, no constant movement. That is the state the cosmos is gradually approaching. White dwarfs, in this scenario, are like heaters that were turned off long ago. They do not produce new heat, but they retain a faint warmth that dissipates slowly. If you could place your hand on them, if that were possible, you would feel that they still hold thermal memory, like walls that absorb the sun during a distant summer and still give some of that warmth back in winter. But that heat is not infinite. It escapes drop by drop. There is no dramatic instant when everything ends. Only a transition so slow that no observer could point to the exact moment when light ceased to be light. It is more like falling asleep without noticing. When you wake up, the world is already in twilight. Now I want you to think about the sky of that distant future, not filled with young stars or brilliant explosions, but populated by these silent remnants, scattered through space like almost extinguished embers. The universe has not become empty. It has become faint. Its signals are soft, discreet, easy to overlook. Neutron stars live this silence in another way. They do not simply cool. They continue to spin, but each rotation is a little slower than the last. It is like a carousel abandoned in an old park. No one pushes it anymore, but it keeps moving by inertia, each turn with less force, until one day it stops without making a sound. For a long time, these stars were like lighthouses, marking precise, almost obsessive rhythms. In the progressive silence of the universe, that rhythm becomes more and more spaced out, not because something suddenly stops them, but because the energy that sustained them dissolves into an ever larger space. Here, Tadler time feels different. It is no longer measured by spectacular births or violent endings. It is measured by wear, by gradual loss, by processes that do not draw attention but that advance without stopping. The universe enters a stage where what matters is not what happens, but what stops happening. And I want to involve you here. Imagine you are sitting in a large room with a fireplace that is going out. At first, the crackling dominates the space. Then only embers remain. Later, not even that. But the room is still there. You are still there. Space does not disappear just because the fire is gone. The same thing happens with the cosmos. Concentrated energy, the kind that allowed rapid change and luminous events, becomes rare, not because it has been destroyed, but because it has been spread too thin. The universe has expanded so much that gathering energy in a single place becomes increasingly difficult. Cold white dwarfs and slow neutron stars then become the most common inhabitants of this landscape. They do not do much, but they exist. They are stable. They persist. And that persistence gives the universe an almost contemplative character. There is no more haste. There is no more urgency. Everything that could be dramatically reorganized already has been. What remains is a kind of cosmic plateau where changes continue to occur, but on timescales so vast that the word event begins to lose its meaning. Imagine a beach after the sea has slowly retreated. The large waves no longer arrive. Only a gentle, almost imperceptible motion remains. The ocean did not leave. It simply changed the way it touches the shore. In this future, interactions between objects become rare. Distances are enormous. Encounters are scarce. Each stellar remnant lives its story almost in solitude, accompanied only by the silent expansion of space. The universe fragments into increasingly isolated islands, not through conflict, but through separation. And here, a very particular sensation appears. Silence is no longer just the absence of noise, it is the absence of exchange. Fewer collisions, fewer mergers, fewer opportunities for something new to occur, not because it is forbidden, but because the conditions no longer favor it. This progressive silence is not sad. It is neutral. It is the logical result of a universe that has used up almost all the available forms of concentrated energy. Like a river that, after crossing mountains and valleys, reaches a wide plain and becomes slow, broad, serene. White dwarfs will continue to exist for times that surpass any human scale. Neutron stars will too. But their influence will become increasingly local, increasingly discrete. They will no longer shape large regions. They will no longer mark vibrant eras. They will become part of the stable background of an aging cosmos. And here I want you to hold on to a final image. An enormous universe, dark in appearance, yet filled with objects that carry within themselves the memory of luminous epochs. There is no drama, no immediate final collapse, only continuity. Silence does not arrive like a blackout. It arrives like a whisper that gradually spreads until it becomes the dominant tone. And in that silence, the universe continues to exist. Without spectators, without urgency, without the need to do anything more. We now arrive at a special point in the story. One where the universe seems to lower its voice even further. We are no longer talking about stars being born or dying, not even about remnants slowly cooling. We are talking about objects that, in some way, seem to stand at the margins of the normal passage of time, not because they are outside it, but because they experience it in a radically different way. Think of black holes not as devouring monsters, but as places where the universe chose to store silence in an extreme form. They are regions where everything has been concentrated so much that space and time no longer behave as they do anywhere else. They do not shine. They do not emit clear signals. But they are there, persisting when almost everything else has changed. I want you to imagine them as immobile guardians in a landscape that grows increasingly empty. They make no announcements. They do not move in visible ways. They simply remain. While stars fade and remnants cool, black holes continue to exist, almost indifferent to the general cooling of the cosmos. What is fascinating is that these objects were born in moments of enormous violence and energy, yet their destiny is profoundly silent. Once formed, they no longer need to do anything. They do not produce light. They do not generate new energy. Their presence is reduced to a pure, stable, persistent gravitational influence. Here time begins to feel strange. For us, the universe ages. For a black hole, change is almost non-existent. The environment transforms, distances grow, energy disperses, but they remain like deep anchors, warping the space around them in the same way for entire eras. Imagine a very heavy stone at the bottom of a lake. The water can move, evaporate, freeze, change level. The stone stays there. It does not control the lake, but it affects it. The water curves around it. The flow recognizes it. Black holes play a similar role in the aging cosmos. As the universe enters ever calmer stages, these objects become proportionally more important, not because they do more things, but because almost everything else does less. They are compact memories of eras when energy was concentrated, when extreme events were common. And here a profound idea emerges. Black holes do not just store mass, they store history. Inside them is compressed the final result of enormous stars, of collisions, of collapses that occurred when the universe was still dynamic. They are capsules of the past, sealed by gravity. I want you to pause for a moment on this. As the cosmos cools and becomes increasingly uniform, black holes represent radical exceptions. They are places where uniformity does not win, where matter does not disperse, where time seems to advance in a different way. They do not move toward thermal equilibrium at the same speed as the rest of the universe. Their interaction with the environment is minimal. They absorb, yes, but they have fewer and fewer opportunities to do so. As distances grow and matter becomes scarce, black holes are left isolated, surrounded by an ever emptier space. This isolation does not weaken them. On the contrary, it makes them the most durable objects in the visible universe. When almost everything else has changed beyond recognition, they are still there, almost identical to how they were when they formed. It is here that we can begin to see them as guardians of deep time. Not because they watch over anything, but because they cross the eras without being significantly altered. They are mute witnesses to a universe that is slowing down. Imagine an abandoned library where almost all the books have disintegrated over the centuries, but a few volumes, bound in extraordinary materials, remain intact. They are not read, they are not opened, but they exist, and their mere presence says something about the past. Black holes are those volumes, almost impossible to destroy. As silence progresses, the role of these objects becomes clearer. They are not engines of change, but markers of continuity. They tell us that the universe does not disappear when its lights go out. It simply changes protagonists. And there is something even more subtle. Black holes, though they seem eternal, are not completely outside of time. They do change, but so slowly that those changes belong to almost unimaginable scales. They are processes that occur when the rest of the universe has already entered a deep stillness. Here, the concept of time stretches until it loses its everyday shape. We no longer speak of millions or billions of years as impressive figures, but as small units compared to what lies ahead. Black holes begin to inhabit a regime where the future becomes almost infinite. If you have made it this far with me, this invites us to look at the universe from that broad perspective, where the initial noise has dissipated and only extremely resilient structures remain. It is not a dramatic ending. It is a quiet continuation.